Kia ora, Year 11 and 12. One of you's asked me to do the Golden Gate Bridge question from this year's algebra paper, so here it is. So I think this question's really something that some of you would have been able to do after level 1 because it's another quadratic applications question. And if you've got a good handle on finding scale factors, then this question is pretty straightforward. There's less insight needed to start this one than there are with some of the other questions in this paper. So we're told that the Golden Gate Bridge has got 2 towers. I'm going to show you the graph, but first I'm just going to read the words and see what we can pick up here. So the height of the suspension cables above the mean water level at a horizontal distance x from the base of the left tower can be modelled by this function. So as soon as you see that, you should be thinking, hey, they've given it to me in vertex form. What does that mean? Well, it means that this point here is going to be 640, 67. And then they've put that into words as well. At the midpoint between the 2 towers, so the towers are here and here, the suspension cables are 67 metres above the mean, right, which is here. And the distance between the towers is 1280 metres. So that all works. This point here is going to be 0, have an x coordinate of 0, and this one here of 1280. And you're told that the towers are 227 metres tall. So even without being given the graph, this is the graph that you should be sketching from those words. And the obvious question is, what's my scale factor? Because we're going to be asked to find out something else about the Golden Gate Bridge. So here's the second part. Well, we're given this lovely graph, and it basically draws everything for us on. And we're told that there's an anemometer to measure wind speed, and it's been put on one of the cables at a height of 100 metres above the mean water level. And we have to find the horizontal distance of the anemometer from the left tower. So we have to figure out this. And this point A we're going to have to find. So let's look at what we know. Well, this tower is 227 metres, but so is this one. So that means that my y-intercept is at 227. That makes it very easy to find my scale factor. So let's do that now. I'll just change to the sparkly pen. So 227 is equal to k times 0 minus 640 squared plus 67. So I'm just substituting in a point. And it's easier, or well, I think it's easier to work with the 0 point, or you could have worked with the 1280 point. It's very little extra work, so either is fine. So working through this, what do we get? Well, 160 is equal to k times 0 minus 640 squared. So 160 is equal to k times 640 squared. I know you're going to reach for your calculators, just be really careful not to round too hard. So k is equal to 160 over 640 times 640. So I'm going to do some very old-fashioned fraction simplification. This divided by this is 1/4. So k is equal to 1 over 2,560. Now I left my whole equation like that. I didn't turn that into a decimal. So you can go and turn that into a decimal if you want, but remember you'll lose a tiny bit of accuracy by doing that. So now we've got our equation. H is equal to this. 1 over 2560 times x minus 640 squared plus 67. Not really very much work so far, and neither's the next bit. All we have to do now is to say, well, here, when y is equal to 100, what is the x value? So I'm solving a very simple quadratic. 100 is equal to this. So let's work this through. I know most of you probably will have stopped watching by now, but maybe not all of you. So there, 33 is equal to that. Multiplying that through gives me 84,480. Now you've got a choice here about what to do. You can expand that all out, collect up terms, and solve it using the quadratic formula or your calculator. But a cleaner way to do it when I've got this squared is just to take square roots of both sides. And remember that it's going to be either positive or negative 290, so the square root of this, 0.6544, is equal to x minus 640. So x will be equal to 640 plus or minus 290.6544. And the value that we want, our position A, will be the lower of those. I'll show you on the graph how it works in a minute. So our position A is at x equals 640 minus, so it works out to be 349.3456. So the horizontal distance, the anemometer, is 349, I don't know, 0.3 meters from the left tower. Let's just go back up to the graph, and I'm also going to show this to you in GeoGebra as well. So hopping back up here, let's see what's going on. Well, here's my 640 here, right? So that's 640, and the two values I'm getting, when you do the takeaway, you get our one, and when you do the addition, you get that one there. But we don't need to find that. Okay, we didn't even need to find like the distance of some bar in between, right? Remember in some of the level 1 questions that you might have looked at last year, it was things like find this distance here. No, you didn't even have to do that. It was just this distance here is how far. So I'm going to see if I can hop over to GeoGebra and show you that that all worked out when I did it in there, just in case you don't believe me. Where are we? It's gone away. No, so don't worry about it. I'll save that for another question. So that's that one done. Just leave me any comments if there are any that you want to do, and I will try and do some of the calculus ones later on today or maybe in the next few days. Thanks for watching.